Hello, everyone, and welcome to today's CX Connect, brought to you by SpeechTech, CRM, Smart Customer Service, and by our platinum sponsor, Bespoken. I'm Bob Fertikes, and I'm the publisher of CRM Magazine, and I'll be the moderator for this week's virtual events. This is our first virtual conference. If you haven't participated in the sessions before this, we've been doing webcasts since 1997. We've done hundreds of them. We do in-person events. The CX conference will have one more session after this session, half an hour after the session ends, and we'll have live sessions tomorrow, Wednesday, and Thursday. So our presentation today is titled Quality, Reliability, Scalability, and Accuracy for the Contact Center. Our speaker today is Emerson Sklar. He is the Chief Evangelist at Bespoken Holdings. And before we start, I just want to explain how you can participate in today's event. We'll have a live question and answer session at the end of the event. You'll notice that there's a chat and a question and answer tab. So if you want to ask a question, please put it in the Q&A, just because if you put it into the chat, we may lose it by the end of the event if there's a lot of people chatting and it kind of disappears. If for some reason we can't get to your question, don't worry, we'll follow up with an email response within a few days of this event. And just for participating in today's event, if you stick around to the end of the event, you could win an Amazon $50 gift card, and we'll announce the winner during Q&A. So now to introduce our speaker today, we've got Emerson Sklar, Chief Evangelist at Bespoken Holdings. Welcome to the broadcast, Emerson.
Thanks so much for the introduction. And again, thank you all out in the audience so much for joining today. My name is Emerson Sklar. I'm the Chief Evangelist of Bespoken, and I'm very excited to be talking to you today about a subject in the conversational world that has really been expanding and seeing significant increased investment from brands all over the globe, both during the last few years, but especially during the last year and a half in these challenging times that we're all faced with. And that is optimizing and modernizing legacy call centers with today's modern interactive voice agents. But before we get started, let's set the stage. So the goal of today's session is to give you the tools and insight that you need to create perfectly optimized modern IVR systems with an eye towards increasing your customer satisfaction, increasing call deflection rates, and reducing overhead and cost. And we want this to be interactive. As was mentioned, if you have any questions as I'm going through this, please put them in the Q&A section. We have several members of the Bespoken team, including our CEO, John Kelvey, ready to answer them as they come in, and we'll leave plenty of time at the end to address as many of them live as possible as well. Now, to give you a bit of background on Bespoken, we are the leaders in automated testing, training, and monitoring for IVR and other conversational experiences. And we're used by some of the world's largest brands to perfect their voice-enabled products. We give your jaws a rest, and we help you deliver stellar conversational products, all without ever having to actually pick up a phone and talk to a virtual agent. We support every platform under the sun, certainly IVRs, but smart speakers, wearables, hearables, automobiles. As we like to say it, if you can talk to it, we can test it. Now, in terms of agenda, I'm going to talk about the evolution of the contact center, set the stage of how we got to where we are today. I'll share some of the challenges that we've seen that enterprises are facing when they're trying to implement new IVRs or modernizing existing legacy ones with AI, and then really what you can do to actually solve those challenges. And I mentioned at the beginning that we've seen extraordinary growth in the IVR market, and some of the reason behind that is pretty obvious. Again, everyone's spending a little more time at home nowadays, and they're placing more calls into customer service teams, and with the stress of the current climate and the increase in the number of such calls they're placing, they're showing less and less tolerance for poor IVR experiences. And it's important to understand the evolution of the call center to really understand how we got to this point and where we can go in the future. In the mid-50s, we saw the rise of the progenitor to what we would consider now to be IVRs, called the automated call distributor. Before this point, call centers relied on manual telephone switchboard operators to route incoming calls to available human agents. But with the introduction of ACDs, those types of calls could be routed automatically to available agents or even to specific agents based on things like telephone number or time of day. At that time, dialing into a call center was still quite expensive for the consumer. And nearly a decade later, when 1-800 numbers were created, businesses saw and readily embraced an opportunity to reduce that friction and to more seamlessly engage with their customers. These systems were still fairly rudimentary, but in the 80s and 90s, we began to see them move away from being purely analog and telephony-based and began being digitized. And with the advent of the actual digital call center, we also saw increased sophistication in speech recognition. No longer were users bound to only using touch tones or extremely limited vocabularies, but they could start speaking in a more natural conversational fashion. With the explosion of the internet in the early 2000s, call center managers suddenly had a way to decouple their teams entirely from the plain old telephone system and provide more scalable and faster support to their customers. But it really wasn't until the last decade that we've seen a truly generational shift. As with many other technologies, organizations have found they can provide infinitely scalable, low cost, and highly effective solutions by embracing hosted cloud products. Each of those shifts that I mentioned has certainly been driven by advances in computing power, but the adoption of them by large brands and enterprises has been driven more specifically by a desire to reduce cost and reduce friction in the customer journey. Similar to the evolution of the call center, we've seen prolific growth in the modern voice assistant world. Twilio, one of the earliest of modern cloud communication platforms, was established in 2008, which is long before the current wave of smart assistants had been born. While not a telephony solution per se, the first and most popular of the modern voice assistants, Siri, was released nearly a decade ago in 2011. There was a lull for a few years, but in the mid-2010s, we saw explosive growth. IBM Watson and Amazon Alexa in 2014, Microsoft Cortana and Google Home in 2015, and Google Assistant and others like Rasa in shortly thereafter in 2016. And since then, there's still been considerable growth, but it wasn't really until the past year that we've seen that same kind of explosive growth in solutions leveraging the modern understanding of natural language processing, specifically designed around customer communication. In the last year alone, 3 of the biggest players in the AI space have released such products: Amazon with Amazon Connect, Microsoft with Azure Communication Services, and Google with their contact center AI. And with their entry, it's clearer now more than ever that modern interactive agents are here to stay. And that really is at the heart of today's contact center modernization effort. So what does that look like? Well, the modern IVR is powered by AI, and it's typically comprised of a few different pieces. You have a telephony gateway that can actually accept a call. You have some sort of mechanism for ASR, automated speech recognition, and NLU, natural language understanding, would provide the capability for handling and making sense of complex user dialogue. And you have some sort of backend service that provides the actual fulfillment logic based on the output from the ASR and NLU. And there on the right, as has historically been the case, you still have human agents at the end of the system to handle inquiries that can't be dealt with a self-service virtual agent. And rather than throw away their existing infrastructure, more and more enterprises are integrating these AI platforms, like the ones I mentioned earlier, into their legacy IVR systems to capture the benefits available from this new age of technology. And so what are those benefits? Well, the goals of IVR modernization typically focus on 3 different metrics. The first, reducing operating expense. The second, increasing the volume of concurrent calls that a given call center and fixed pool of human agents can handle. And finally, increasing customer satisfaction. And so all of those have very, very tangible monetary and reputational benefits, and all also are largely dictated by the objective quality that your newly implemented system possesses. And what does quality look like for an IVR? Well, let's take one of these modernization efforts in practice. One of our favorite Bespoken customers, EPCOR. Formerly known as the Edmonton Power Corporation, EPCOR is the largest utility company in Alberta, Canada. They manage water, wastewater, natural gas, and electricity distribution for millions of customers across both Canada and the United States. They have a large contact center with a number of human agents, and they actually have to staff it with temporary on-demand agents during seasons of typical increased load, like wildfire season. And even with that additional staffing, they aren't able to successfully handle the huge volume of calls that may come in after a significant storm or after a power outage. Their existing legacy IVR was largely DTMF based, which means that every phone call for someone to report an outage required actually talking to a human agent. And like I was saying earlier, to reduce cost, to increase throughput, and to increase customer satisfaction, they decided to embark on a journey of modernization with Twilio Autopilot, actually providing that AI background. But they had a number of challenges. And these challenges we see actually quite frequently. They're really quite common for even the largest of enterprises that are following the same path. They had a very tight time frame. They had a need to get the system functional and deployed in under a month. They had a team that was very, very skilled with traditional IVR processes and very skilled in web and mobile development, but lacking in conversational AI expertise. Being a Canadian company, they needed to support both Canadian English, Canadian French, and then for their US customers, needed to be able to support US English as well. And their testing team was quite small. No one spoke Canadian French. Very few of the members even had Canadian English as their primary accent. And the initial set of functionality that they wanted to support, again, power outages, had 40,000 unique addresses in the Edmonton, Alberta, Canada market. As is often the case with many of these engagements, had tremendous executive visibility. It was a big investment that they were making. And the executives had an expectation that the end product, the end result, would not be as good as their existing one, but would be much better, that the quality would be much higher. And figuring out how to measure and how to think about that quality was a challenge for them, is a challenge for many organizations. So if we think about what defines successful IVRs, what defines high quality ones, if we first think about it from the end user perspective, from the actual caller, there are 5 different categories that we see. The first is how knowledgeable the agent is, how well it's able to understand the varied queries you might have, how quickly you can get an answer to whatever your inquiry is, how clearly you understand what you can say to it and what it will say back to you, how likely you are to be able to resolve the issue, resolve the reason why you're calling the first time. And then finally, if it is something that requires some human intervention, if it is something that requires you to speak to an actual call center agent, how easily, painlessly, and quickly you can get to that agent themselves. And if we think about what drives then satisfaction for the people that are responsible for the IVR, either for the operations team, for the contact center team, or for an implementer, an SI that is actually creating it, there are also 5 characteristics that we see. The first, simply how easy it is to implement. No one wants to undertake some new onerous task if it's going to take them years to get back to parity with their legacy system. Obviously, the price and how quickly they will see a return on that investment and how significant the return on that investment will be down the line. How significantly they're going to be able to increase call deflection. Are they going to be able to reduce the operating expense and reduce the load on those call center agents and enable people to serve themselves and find solutions to their issues through this virtual agent? And then finally, how performant it is. Is it reliable? Does it work not just today, but work every day in the future? Is it able to scale not just to the average baseline load that you might have, but in periods of significant load, like if there is a power outage and you have thousands of concurrent callers coming in? All of those things, again, are measurable, and all of them are directly impacted by the quality of the IVR system that you're implementing. And it may seem easy. You might think, oh, these platforms are so sophisticated. I can just snap my fingers and release this world-class, incredible product. But there are many challenges. It is not simple even for the most experienced organizations. So what gets in the way? Well, the first challenge, the first problem is that the way that people typically measure that quality, the way people think about it, is with humans, is with manual testers. And for anyone that has done any software development in the past, manual testing is expensive. Paying someone to pick up a telephone and read the same script over and over again, speaking at human speech speed, walking through all the different flows in your system is time consuming and very expensive. It's also quite tedious. I've done research for prior companies where we find that the quality of someone's voice, the characteristics of their own voice, starts to deteriorate between 1 to 2 hours of them following some kind of script for a voice-enabled product. And it's simply no fun to sit and read the same script day in, day out, over and over again, dialing into a system as you're developing it. The third challenge there is that voice testing is infinite and very, very repetitive. There are a truly infinite number of combinations of things that you might say. There are infinite combinations of ways that people might say it, of different vocal profiles, different acoustic environments you might be in. And trying to capture all of those combinations, trying to replicate those and replicate the real end user experience is frankly impossible. And so that's why automation is absolutely critical, absolutely essential for successful speech and conversational enabled products. And so let's think about some test cases. I have 2 different tests there, pretty simple for me calling in and reporting an outage and me calling in and checking out the status of the outage. And so if I think about the differences between doing this with manual testing, manual testers, it might take me 3 minutes to write that manual test case, and it's probably going to take me the same 3 minutes or so to write the automated test case version. And those versions that you see on the screen, those actually are Bespoken's real automated tests. That's exactly what they look like. Very simple English-like syntax, looks probably very much like the manual test that you have today. So it might take the same amount of time to write a manual test versus an automated test. But if I'm a tester and I need to go and actually run through those flows, I need to execute those 2 cases, maybe it's going to take me another 3 minutes or so to do so. But if I have the automated test, it doesn't take me 3 minutes. I can do it literally at the click of a button. And if I'm developing a new IVR or adding new functionality to an existing one, and I have to do it multiple times per day, every day for a few weeks, the amount of time that I'm wasting doing the same repetitive task over and over again really does significantly start to add up. But with automation, it doesn't. It takes me no more time to run it, no more clicks of the button to run it the 100th time than it did the first time. And so how does that work? Well, the first step is writing the automated test cases. And we try to automate as much of the automation process as possible. And so what we can do is actually automatically generate many of these test cases from your IVR's conversational model. I mentioned that we support virtually every platform under the sun, so it really doesn't matter what format those are in today. Similarly, if you have manual test cases, it's very, very easy to convert those into that simple format that you saw before. We actually even provide a mechanism for people to turn the real calls that they might be placing into these automated tests. So even someone who's totally non-technical can still participate in the automation process. After we have those test cases, we place real phone calls. And so we leverage what we call virtual devices. So instead of having a real human sitting with a real phone actually placing the phone calls, we do that, but it's all entirely automated. And so the benefit there is that we're not limited by the number of humans that you might have. We can scale these infinitely, enabling you to actually conduct very broad scale performance and load testing without needing to recruit a large number of manual testers. We're leveraging neural text-to-speech tools to take those test scripts that you've written, convert those utterances that you had typed out into real audio, and sending them to the voice platform. And these virtual devices interact exactly the same way that a human would. They're walking through the flow, responding as the virtual agent is talking to them, hitting DTMF tones, whatever the input might be. And we are constantly capturing and analyzing responses that are coming back from the virtual agent. The next step, just like if a human were doing this, where you have to look at the results and try and analyze them, we strongly believe all of that should be automated as well. And so we help people push those results to whatever platform they're most comfortable with, so they can see them in the tools they already know in a format that's easily consumable and actionable for them. Once you have those results, once you have that insight and you've fixed some defects, you've made some changes to your conversational model, rather than needing to have somebody on call, you can pick up the phone and dial in and verify that it's actually fixed. Again, you can just click a button, run those automated tests again, and immediately verify the impact of the changes that you've introduced. And so that has some significant benefits over, again, over manual testing. The first is faster time to market. People who leverage automation in their voice development lifecycle see an average of 30% reduction in time to market and time to deployment. And that means then that you can start realizing the greater ROI from embracing these types of technologies that much faster. It also lets you focus on what's really important, on actually enhancing and further expanding the capabilities of the system, providing more self-service functionality, rather than spending lots of time waiting around for manual testers to try and see what's going on with the system. It's significantly less expensive than trying to do the same thing with manual testers. It's also orders of magnitude less expensive than any other type of automation mechanism that might be on the market today. And our goal with this manual testing is to try to reduce, our goal with the automated testing is try and reduce the manual testing required by at least 90%. Now, there are some cases where manual testing is still beneficial. A good example with EPCOR is reporting that there's an emergency, that there's a down power line, that there's a fire, there's been an explosion. You know, those types of things you want a human to do, so that when it immediately routes it to someone in the contact center, you can say, hey, there's not really a fire. I'm a tester working on this team and I'm just testing it. But the vast majority of test cases you can very rapidly and very easily automate. And again, let your team focus on more high priority tasks. It also significantly increases that end user CSAT. It lets you exhaustively exercise all of the different flows, all of the different paths through your system, ensuring that they do actually work as you designed them. And because we're leveraging text-to-speech tools, it lets you test with languages, accents, ages, genders, beyond those of the fixed, smaller team that you might have. For EPCOR, for example, I had mentioned that being a Canadian company, they needed support both Canadian English and Canadian French. I myself can read and write a little French, but my spoken French is very poor. I would never be able to help them manually test a French-speaking call center application. But you can very, very easily write one of these tests in French, pick a French text-to-speech voice, and truly be able to see exactly how it's going to perform from someone who would be a native speaker. I also mentioned a benefit of using virtual devices over trying to do it with manual testers is that it is infinitely scalable. And so those same tests that I already have written, I can execute in parallel at huge volume, huge scale, to really get a clear indication of what the performance of the system will be under a realistic real world load. So that was the first challenge about manual testing. The second challenge is that speech recognition accuracy is absolutely paramount, and it's something that is frequently overlooked when people are developing new AI-driven NLP products. If you look, it doesn't matter whether it's on a smart speaker in an automobile, whether it's a virtual agent in an IVR, the number one characteristic that determines an end user's perception of the quality of some sort of conversational product is how well it understands them. And even the largest teams, even the Amazons of the world that are actually creating these platforms, don't have enough warm bodies, don't have enough people on their teams to represent all of the different vocal profiles of their real end users. We have a friend who likes to say that everybody's thumbs are the same, but everybody's voices are different. And what that means is that if we were testing a mobile app, I could test it probably about the same as everybody out there in the audience. We can tap on buttons the same way. But fundamentally, my experience with a voice-enabled platform is going to be very different from your experience, simply based on the characteristics of our voice. So how do you fix that? Well, let's take a thought experiment first. We know it's tough for AI, but it's tough even for humans. If I wanted to call into a call center and say that there's a power outage and my address is 123 31st Street, does that mean my address is house number 123 on 31st Street? Does that mean my house is house number 1 on 23 31st Street? Does it mean that I live at number 120 on 331st Street? You know, those things are tough even for people to try and understand, let alone for some kind of AI-driven virtual agent. And so it's critical to have a way to measure, to evaluate, and then to improve that speech recognition accuracy. And that's why training is absolutely essential for successful IVRs. And this training is an iterative and cyclical process where you identify what people might say and how they might say it. You measure the performance of the existing system. You analyze the results to determine trends and underlying biases in the system. And then you tune and tweak the platform to improve that capability. And so let's dive into that a little bit. So the first step is measuring your current performance, figuring out where you are today. You want to figure out what the important parts of your conversational model might be. So reporting a power outage, for example, is obviously very important. That's the initial critical part that they had targeted. You want to identify the variations of different things that people might say, the different carrier phrases, different slot values, different colloquialisms, perhaps. So you have some examples of different ways you might say your power is out. You also want to identify the vocal profiles of your real end users. If I'm releasing a system that is going to support the Boston market, the text-to-speech voices that I'm going to need to use, the audio that I'm going to need is obviously very different than if I have one that is for people in California or people in Texas. So it's really important to understand, who that target market is. And then what you do is you take that superset, that matrix of all of those different combinations, and you send them to the voice platform to get statistically significant, quantitative, and objective information about what that performance is. And then from that, you start to analyze the results. And so I have some examples of what this test might look like. I might use, I want to report a power outage, and I use it with a US English male voice, and it works great. That one might be fine. I do it with a US English female voice, works great. I try to do it with a Mexican Spanish male voice, still speaking English, and see that, that instead of it understanding me saying report, that it thought that I said repair. And that's a very common, one of the low-hanging fruit type issues that we see quite frequently, are those homophone type issues. I might see that in this case, I say my lights aren't working. That might seem like a silly thing somebody would say for a power outage, but maybe that's something that I forgot to build into my conversational model. And so we know we need to add that in as additional samples. I might say, the power is down, and because I have too many sample utterances in a different intent, it might interpret anytime I say down as like a downed power line and think that there's some sort of emergency. All of those things are very easy to rapidly identify, and there are differences in how you might address them based on the system that you are currently supporting. But every one of those systems does have different levers that you can pull. Every system has ways to help manipulate their understanding and help fine-tune them. And that really is critical. The next piece, though, I mentioned that it is cyclical and iterative, is to do it again. And these are AI-driven platforms. They're constantly evolving. Some of that is human evolution, some of that is AI-driven evolution. But it's tough to figure out what is going to happen when you make even very, very small changes. And we see time and time again that people will make what seems like a fairly simple, common sense, or obvious change to a conversational model, and it has drastic, hopefully positive, but oftentimes negative downstream consequences. And so the key here is to do this once, to measure a baseline, And then anytime you make a change to your conversational model, rerun this type of test to ensure that you're always driving towards optimal quality. Many times you may have anecdotally felt that you made some sort of change and it got better, or you made some sort of change and it got slightly worse. But really, the only way to know that you are actually trending towards optimal speech recognition, the only way to know that the changes that you're introducing are heading in the right direction, is to have that quantitative and objective baseline that you can do comparisons, apples to apples comparisons, for each change that you introduce. And this progression that we see, by the way, from starting at 75% to getting to the mid to high 90s is quite typical with what we actually see. And so the benefits there from the training are significant and very tangible. Time that you spend with this training drives greater and greater ROI. Every small amount of increased speech recognition accuracy that you can generate, that you can capture or realize, significantly increases call deflection. Similarly, every small bit of speech recognition accuracy that you can generate significantly increases that first call resolution rate. It also simply drives greater satisfaction for your customers. I mean, again, I'm sure everyone has had an experience where you dial into some sort of call center. You're trying to call your bank to check your account balance, and it gives you the weather today, or it routes you to a human agent, or it gives you someone else's account balance. All of those things are terribly frustrating. All of those things drive increased load on the human agent, and increased frustration with those human agents as well. And all of those things are very, very easy and very straightforward to optimize for and to increase the quality of the system. We typically see that with the modern speech recognition and AI platforms, we typically see that people will begin between 60 to 75% or so successful speech recognition. And you may say, okay, that's not so bad. 75%, that's only 1 in 4 is going to have an error. But that's just with one utterance. If you have a call center application that is a multi-turn dialogue, I call in, I say I want to report a power outage, I give my address, I confirm that's my address, I say they're right, and it hangs up on me. The likelihood there is that virtually every single person is going to have an experience where it doesn't understand something that they say, even with fairly simple or fairly commonplace accents. What we aim to do with this training process is aim to get people to realize a 50% or greater reduction in speech recognition errors. That may seem like an extraordinary leap to get from where you began to where ultimately where you want to be, and it is an extraordinary. It really is the power of being able to leverage automation like this. In addition to those benefits, it also gives you as a business additional ammunition to make informed decisions about how much more effort you want to put in based on your business's priorities. If I know that it takes me 1 week to get from 60% to 75%, and I know it takes me another week to get from 75 to 80%, and then it takes me a week to get from 80 to 85%, and it's going to take me a month to get from 85 to 90%. That type of information, I mean, it's still valuable to try and drive that speech recognition accuracy up as high as possible, but it enables your developers, it enables your call center managers, it enables your operations team to really make informed decisions about when they want to build that into their voice development lifecycle and what the potential impact both in the near term and in the long term would be for the business, for the enterprise. Now the third problem. So we talked about the pains with manual testing, talked about how important and often overlooked speech recognition accuracy is. The third problem is that modern IVRs are a heck of a lot more complex and challenging than they used to be. AI is a new paradigm. Even very, very experienced, very well-established organizations that we see that have a great history of success with legacy IVRs, perhaps have a great history of success with web and mobile applications often struggle to understand what they can do with these modern AI platforms. And it would be great if I could say that Amazon, that Google, that all of these organizations do a great job of articulating what controls you have, of articulating how you can get support, of how you can fine tune these, but they often don't. The AI systems, as I mentioned earlier, are constantly evolving. And so you may have something that performs perfectly today that may not perform perfectly tomorrow. It's not like with mobile. If I release an iOS app, I'm pretty well assured that it's going to perform the same today and same tomorrow and the same a couple months from now until Apple releases some new iteration of their operating system. But on a day-to-day basis, hour-to-hour, minute-to-minute basis, the behavior of these AI-driven systems can change quite drastically. And the last, again, is that it introduces complexity. People are, for the right reasons, absolutely, but people are connecting these systems to more and more backends. They want to expand the capabilities of these virtual agents. They want to try and automate the processes that it's able to help serve customers with. That reliance on those backend systems, those integrations, introduces complexity that makes it significantly more challenging to keep track of, significantly more challenging to try and validate the performance of, or validate the capabilities of than was the case even just a short 5 years ago. And so it's not just enough in pre-production to know that it works the way that you designed it. It's not just enough in pre-production to ensure that you've driven the speech recognition accuracy as high as possible. It's not just enough even, the day, the week, the month that you release it to ensure that those things are the same. You need a long-term, sustainable, and maintainable strategy to ensure that the system is performant every single day, every single minute at all times. And that's where this notion of monitoring comes in. And the monitoring really delivers confidence. It lets you sleep easy at night. It means that you won't get any angry emails from your customers or angry tweets when your system is not working. It lets you know that even if you don't have somebody sitting in an office actually dialing into the IVR, that it's still behaving the way that it should. And so the key here, we at Bespoken are big proponents of DevOps. We actually are so passionate about it. We help many of our customers stand up brand new DevOps environments if they don't have one. That's how important we think it is to the voice development lifecycle. And so the process here is to take these automated tests and to integrate them into whatever existing infrastructure you might have today, or stand up a new one. And that's important because it gives sort of a centralized location for the automated tests that you have. It also lets you have a centralized location for all of the results, and it lets you set these tests to be run without a human actually clicking a button, to be run automatically. It's automating the automation of your experience. And two different types of scheduling or of automatic execution that you want to have. The first is scheduled, and so our recommendation is always to have very, very frequent, typically hourly, although we have some partners who have absolutely mission critical call center applications that they need to do it on a minute-by-minute basis. But you have some very, very frequent smoke tests, sanity tests, whatever you may want to call it, making sure that the lights are on, that the plumbing is still working, and then progressing towards daily or weekly, more broad and more feature complete regression tests to ensure that everything sort of down the line is still functioning as you have designed it. You also want to make sure that you have tests that are triggered anytime you make a change. And so when you check in new code, perhaps you've changed the back end a little bit and you check in new code, you want those tests to kick off and run against your integration or your test environment before that code gets out into production. We talked about the speech recognition accuracy part. You certainly want all of those tests to be run before you deploy a new conversational model. And if you do that, it means that you never risk having an opportunity where bad code or bad experiences actually get out into production, that any of those issues are caught long before your customers would ever see them. You also want to make, for the tests that are running against your production environment, you want to make sure that you have automated notifications. So it's not me coming in at 8 a.m. on a Monday morning and logging into my DevOps tool and seeing, oh, my tests have been failing all weekend. I had no idea. You want to be able to have real-time, immediate insight into what's going on. And depending on the issue, you may want to notify different people. So if there is some sort of issue with the telephony gateway, we dial an automated test and nothing picks up. That could be your IT operations team. If there's something wrong where the conversational model changes that you introduced are causing the existing test to fail, that could be the voice development team, it could be your AI team. Again, all of these trying to streamline this process and eliminate as much as possible the manual human effort required pays significant dividends, both immediately and in the long term. And so that has a few different benefits. Again, I sort of mentioned about this, but the reduced maintenance cost, making it so that you don't need a human to be there to hit a button or to manually review results, makes it so that you can immediately gain insight into the performance of the system, makes it so there are no surprises. I can't count how many times we've worked with contact center teams that say that their CEO tried to call into their system and it didn't understand them or it didn't work for him, and he sent them a mean text. Again, it makes it so that before any caller finds any of these issues, you're the one who finds them first. And for people who are developing IVRs on behalf of other customers, for implementers, for VARs, for resellers, it serves as sort of a neutral third-party objective proof of the performance of the system. It's something that your team can point to and say, see, we are hitting our SLA of 99.9% uptime. You asked us to improve the speech recognition accuracy, and see, we were at 65% last week, and we've spent this time, and now we're at 75%, and that translates to X dollars in savings over the next month. It again removes anecdotes, removes subjective information or subjective experience. It provides that objective source of truth for all of those efforts. And so let's come back to EPCOR. All of those examples that I gave, all of the metrics and data was actually directly from this project with EPCOR. Again, they had a tight time frame, about a month, to get this product out live. Team without conversational AI experience, didn't match the vocal profiles of their customers, and had a huge volume of work that they were trying to include in their initial set of functionality. In under a month, we partnered with them. We implemented all of those different capabilities that I had mentioned. We did 4 rounds of that training process, and we set them up with an easily maintained, fully automated DevOps environment. And the outcome was significant. I mean, we were able, because we can use customized voices that really match with their customers, how their customers sound. We immediately identified significant issues that were simply pathed through the application that they could not have tested before because of the limitations of the voices. We cut the manual testing out by over 90%. Again, there's some areas where manual testing is still required, but the vast majority of that was taken away. We cut out the speech recognition accuracy errors by 49%, again, significantly driving up call center deflection, first call resolution rate, and customer satisfaction. And we used those same tests to conduct very large-scale load tests and identified bottlenecks in their back-end systems that they were integrating that would have prevented them from ever trying to achieve the real-world load that they get every time there's a big storm. And after they correct those issues, again, at the click of a button, we're able to run those load tests again and validate that the throughput for the system was over 6x greater than what they had before. And those outcomes are significant, but they are the type of outcomes that we try to drive and that people who leverage automation in the voice development lifecycle can realize in every project that they might work on. And yeah, so I'm going to go ahead and pull up the Q&A. That was the end of the content, but I would love to hear any of the questions that you out in the audience might have about this process.
Wonderful presentation, by the way. I've got many questions myself, but here's a question. What languages and accents do you support?
Yeah, great question. The simple answer is that we support every language and every accent that any of your customers, any of your real applications could possibly support. The more accurate answer is that we leverage typically Amazon Poly, Google Cloud Text-to-Speech, and IBM Watson for doing our text-to-speech capabilities. And between those, they have hundreds and hundreds of combinations of accent, age, gender, and language. We also do, however, have some use cases where customers might have a really interesting product, a really interesting challenge. You might want to have something that is Ecuadorian children and the specific way that they might speak supporting this product. And that's something that that Amazon or Google might struggle with. And it's actually just as easy for us to leverage real recorded audio instead of text-to-speech audio, instead of generated audio in these tests. And so if a company has banks of audio that they've recorded from the real production system, if they have if they have a partner who can do crowdsourcing, or even directly through us, we have a capacity to do crowdsourcing of real audio as well. It lets you get the best of both worlds between the generated and the real world audio.
Great. Just for my own edification, do you guys normally come in, in conjunction in a well thought through plan to do all the testing and training? Or do you come in sometimes at the last minute to save something that may not have gone the way the company had originally intended it?
Yeah, well, it's like a tree where the best time to plant a tree was 20 years ago, and the second best time is today. The best time to start with this type of capability is very early on in the life cycle. But we very, very frequently have people like that case that I showed, where they are towards the tail end of their implementation and are trying to wrap things up, or they have something that is out in the market today and they need to improve the quality of it. We run every relationship that we have with every one of our customers, every one of our partners. We like to say that we run it as a white glove service, and we really are invested and interested in success of the people that we work with. And so when we get started, we very rapidly do any of the initial configuration that might be required. We help write the initial tests or automatically generate them from the configuration. We will integrate it into whatever environment you are already using within your organization. And we will run the tests and then provide a customized roadmap about what you should focus on next and what might be longer term things to focus on. And whether that is a month before you need to go out and release, or it's something that's been out in the market for a year and you're pulling your hair out trying to figure out how to make it better, we are excited and invested for helping people improve the quality throughout the life cycle.
Okay, here's a question. Do you need a developer, or do you need to be a developer to do this type of testing, or can you explain how that whole process works?
Yeah, great question. I had shown those simple scripts, and those are great because, again, they let everybody participate in automation. We see at many of our partners actually that they have business analysts or even interns participating in it, people that are totally non-technical. We do also have more technical ways. If you want to run a test with 1 million combinations of different addresses, for example, it's going to be much easier just to have that in a CSV file, some spreadsheet somewhere, and have a code written test that plows through them and does all of the calls. But no, you definitely do not need to be technical. You definitely do not need to be a developer to be able to contribute to this automation lifecycle.
Okay, great. And what verticals do you see that or this is most useful for?
Well, it is useful for any, and we we can demonstrate those same kind of significant benefits regardless of the vertical. I would say, though, that there are some that are more metrics focused or have a greater eye towards the historical performance, for whom these increases can seem more significant. So things like public utilities, financial services, hospitality, those or even telecommunications. Those are some of the ones that we see most frequently that have that historical experience and are laser focused on the metrics and data.
Okay, great. I think we are out of questions, but fantastic presentation. Got a lot of compliments in the chat. I want to thank everyone that joined us today to view this event. Everybody that asked questions. Also, really like to thank Bespoken as a sponsor, without which we wouldn't be able to present this type of content. Also like to thank our speaker, Emerson Sklar, Chief Evangelist at Bespoken. And if you'd like a copy of the presentation or have a colleague view the presentation, don't worry, you'll receive emails from us once the presentation is archived. So that's not going to be a problem. It'll be archived for at least 90 days. And also like to thank our winner today. And our winner is, who is our winner? Oh, Craig Dedman. Sorry, jumped right off that. Congratulations, Craig. We'll get in touch with you via email and get you your card. I would also, we're wrapping up right now, so we've got a roundtable presentation coming up at 3:30. So please log back in a half an hour or so and join us for that. And thanks so much, Emerson. Thanks so much, Bespoken, and thanks to everyone for joining us.